to another FARCROSS mini interview series. My name is Magda Zafiropoulou from UBTech Energy, and today I'm very happy to have here with me Mr. Marko Gabrovšek from CEO of C&G SKUPINA Group. Thank you very much, Mr. Marko, for joining today's interview. And I would like to start with introducing yourself and your expertise, or what is your role in the project?
Okay, thank you. I'm glad to be able to share information with you. So what is actually first, C&G Group is a company specialized in providing services in the field of power supply, energy protection, control system, efficient energy solutions, and so on. So we are both. We have the company which is doing the consulting services and the company which is doing the construction services. So C&G Group is the leader of the work package 5, and I personally coordinated the work of partners of this package, of course with great support of our colleagues from, first of all, of C&G. As you know, Dr. Lovrench was very active. Then a group of people from OTLM and people from the University of Zagreb. We got important support from partners in the selections of the location for the installation of sensors, the establishment of communication, the processing of the data, and the preparation of the interim report. If I can touch the deliverables, so C&G was the one who prepared the deliverable 5.1, which is a description of location, method, and IT environment with the results. Our partner MEI prepared the deliverable 5.2, which is about the results of the proposed laboratory tests and integration of the system components. HOPS, this is the transmission company from Croatia. They were responsible for deliverable 5.3, which is the report on intermediate results of the demonstration performance. And now we just completed the deliverable 5.4, which is the description of the updated expert system. And we are starting to prepare our last deliverable, our last report, which will be done by MEI, which is deliverable 5.5, which is report on the final results of demonstration for the pilot 2, as it called the project. That is my first, let's say, introduction. Maybe it was too intensive, it was too much, or?
It was very interesting because we actually understand what are the partners that participate in your work package.
Oh.
So could you please explain to us what is the main aim and the purpose of the solution proposed by your demo, the DLR-H demo?
Yes, so our main aim is to implement a complex DLR-H system. This means DLR is dynamic rating with health issues with two different approaches. So one approach is to do it with the sensors. So we applied two different sensor technologies, and the second issue is to actually to do it through data from let's say, how you call it, neurological network. And also one aim is the aim of DLR is to to be able uh, to for the overhead line to have the optimum ampacity, to calculate the optimum capacity of the overhead line. And on the other hand, we were trying to see what are the health issues of the overhead line if it is if it is deployed in such a way. That is the main aim, as I can see. Uh,
So
so
actually,
if I
what
summarize, yes, please. Just ask.
actually, what kind of equipment is used and where it's installed?
So equipment is used. We used different type of equipment. We used OTLM as a sensor. We used also the sensor from line vision. So this is Monitech, which is it's also line vision is the company. We use the weather station. We use the Imotol sensor. So this would be basically all. Say, let me see. Yes, OTLM, weather station, Imotol, and line vision sensors. So, and they are installed on the 8 overhead lines. Were installed on 8 overhead lines. So let's see, 4 interconnections. We have Austria toward Hungary, so Hungary toward Slovakia, Croatia toward toward Bosnia and Herzegovina, and Greece toward Bulgaria. These were international connections, and then we had it on 4 internal OHLs. This was in APG, Austria, in Croatia, HOPS, in IPTO, in Greece, and in Mavri, in Hungary. So there were 4 interconnections used and 4 internal overhead lines used. Was I clear?
Yes, yes, that was indeed very interesting. So I was wondering if you can shortly present us the dynamic line rating and the health monitoring.
Okay. So let's see what is dynamic line rating. Is dynamic line rating uses the fact that the ampacity of overhead line depends on the ambient conditions, and these overhead lines are designed for high summer weather conditions. But these weather conditions usually are only for some time when it's very hot during the summer, and overhead line at that time cannot use very high ampacity due to bad cooling of the conductors. But during the year, you can deploy this overhead line much more because there are more cooling, temperature is lower. Usually you have some wind, which helping to cool the overhead line. So dynamic line rating is actually about that you deploy your overhead line optimally during the whole year. And by the experience and by the data, we see that we can increase ampacity, so power which goes through the overhead line, from 15 to 40% most at least many months of the year. The major task of DLR is actually to derive the present and forecast the future ambient conditions, calculate the current carrying capacity, this is ampacity, and integrate these results to dispatch center processes considering adequate security margins. That means that you, in the main, during you are trying to measuring the temperature of the conductor, but you are not you are not allowed. You actually measure, or actually you calculate also the safety distances which cannot be, so you cannot go over the safe distance. So you go with the optimum production, optimum ampacity of the overhead line, but with the safety, within the safety possibilities. So safety is very important. So you cannot go with the sag below the security limits.
Great. That's indeed very interesting. And could you please explain us how C&G integrated the sensors, the ITLM sensors and I-model sensors?
Okay, I will explain it to you. So OTLM and E-model sensors were integrated in order to establish the health index. So with the OTLM sensor, we were measuring forces considering to the sac of the conductor, and the E-model sensors were installed in the sac, in the legs of the structures, in order to measure all the forces, residual forces in the legs of the construction of the construction of overhead line. And with this integration, we could get information how much forces in the upper side of the tower actually what they do with the legs with the legs of the construction. If you get me. So that is the main purpose of the getting of the health index of the structure. How this is with the bigger ampacity, when you have higher forces, what does it happen actually to the structure of the overhead line? It's very important for us in order to see. You can then predict what is the, for example, what is the life expectancy of such an construction. Yes.
Indeed. Who is the customer of the equipment and the solutions proposed by the demo?
Oh, I suppose that it could be any transmission and a transmission system operator, and even, of course, also some distribution companies all over the world. Because you see, the most important is electrical energy today is the electrical mobility with more or less with the ecological standards, high ecological standards. Electrical energy consumption is becoming higher and higher. But on the other hand, you have a big difficulty to build new overhead lines, because you know, at least in our country, I can say, if you want to put if you want to build a new overhead line, it takes a lot of time in order to get it through the all administration procedures. This is basically in all countries. So you can so employing these sensors and employing this I would say the experience and the expertise of us, you can prolong the life of the overhead line. You can use it optimally concerning the weather conditions. You can also actually do the maintenance process according to the data of your health index of your overhead line which you get. So there is a lot of practical uses of this data which we got, and especially what else was proved here. So you see, we put this sensor on the interconnections between countries, which are usually the bottlenecks or the as you call it, congestions. Usually there can help, congestions can come there. So you are actually, you can really operate it optimally on the critical points of the grid.
Since FARCROSS project is coming to an end, could you tell us what is the future development of equipment and services in Work Package 5 DLR demo?
Okay. Future. European projects should include and support development ambitions in this area, namely toward the universal goal of asset management and AHI calculations of the overhead lines. Let me explain that. Today, if you have asset management of the components of the grid system, like transformers, you have actually all asset management and AHI techniques are well known, but overhead lines is the only component of this grid system which has not yet, where these methods of asset management and AHI are still in some phase of development, and it needs a lot to be done that we get to the same point at other components. So the next projects should include technologies for health monitoring, like inspection of aged conductors with non-destructive methods. So like robot technologies, drones, you have a lot of technology today to identify visible defects on the surface of conductor or detect more severe cases of corrosion of these conductors, ICSR conductors. And of course, this is one thing which should be done in order to get further knowledge of the health and of the asset management status of the overhead line. On the other hand, employing sensors like, for example, OTLM, which I know the best, on the both sides of the tension tower. Tension tower is where two different spans are connected. On the tension towers, we could compare forces which one side is causing to the other side, and again we could see exactly what this is causing to the tension tower exactly. Those are many ideas still, and we have work to do to be able to actually at least to be somewhere near where the another components of the grid are, if I'm correct. So I know that because from my experience, I know that really a lot was done about big transformers, about measurement transformers. A lot is known about switches, and so, but in the overhead line, still we are actually not doing the first steps, but we are in the middle of the development of the asset management and the AHI, asset health index. That is my information for the future.
Great. So, Mr. Gabrovšek, thank you very much for this really interesting interview. And we are eager to see the final results of your demo, of course, and the project. Thank you
Thank
very
you very
much.
much. Thank you.